Okay, this is still section 1.1. This is video C. We are still talking about analyzing categorical data. I have parts of these notes filled out, you'll notice as I scroll through, but we're going to talk through everything here. It says when a data set involves two categorical variables, okay? So we would be collecting two pieces of information, say, from each person, and the data we're collecting is categorical in nature. A lot of times this is done by gender because they want to see how did the females answer this question as opposed to the males. So gender is usually one of the two categorical variables. We examine by either counts or percents in various categories for one of the variables, okay? So we call this a two-way table. Okay, a two-way table is what describes two categorical variables organizing the counts according to a row variable and a column variable. Okay, of course we know that the rows is what is horizontal and the columns are what are vertical here. Okay, so in this particular example, it says a survey of 4,826 randomly selected young adults between the ages of 19 to 25 were asked, what do you think the chances are that you will have much more than a middle class income by the age of 30? Okay, and so they were able to kind of check off one of these four answers, okay? They thought there'd be almost no chance that they would have a lot more than a middle class income by the time they were 30. They thought there was some chance, but probably not, 50-50, good chance, or they were almost certain they would have much more than a middle class income by the age of 30. Okay, this is a two-way table. You can see in this case, the rows are representing the responses to the survey, and the column variable is the gender. Okay, the column variable is the gender. The nice thing about this is we get these totals all the way on the right. We get these totals on the bottom, so we know how many females were surveyed, how many males. We know the total number of people who answered each of these responses. So down here in question 2, it says, what are the variables described in this two-way table? And of course, the variables are what's along the top here, the gender, and then what's along the side, which are the responses to the survey, okay? You'll notice they did a really nice job labeling this here. They've got even a title to this two-way table. Okay, the next question, how many young adults were surveyed? Well, we're going to get that right here in this bottom corner. There's a grand total of 4,826 total young adults surveyed. That should be the total of this column. It also should be the total of these two rows. Those definitely need to add up here. Okay, what we're going to focus on, though, is we're going to focus on something called a marginal distribution. Okay, and this is called a marginal distribution because it's found in the margins. Okay, so you'll notice those totals I was just describing, okay, here and here. That's what we're referring to when we talk about a marginal distribution. It's one of the categorical variables. So it's either these totals, which is referring to the gender categorical variable, okay, or it's these totals, which are referring to the responses to the survey, okay, that marginal distribution here, okay? So it's one of the categorical variables in a two-way table of counts, and it's the distribution of the values of that variable among all the individuals described in the table, okay? Now this is very important. Percents are often much more informative than counts, especially when you are comparing groups that are different sizes. Okay, so it's always best to go with percentages. And you'll notice we're not given the percentages here in this table. We are just given the counts, okay? So if we wanted to know what percent was everybody who answered almost no chance, well, then we would need to take the 194, we would need to divide that by the grand total, and then we would have a percent here. That's what we're talking about when we say a marginal distribution, okay? So let's take a look at that. On the next page here, we can see how we can examine these marginal distributions. We're going to use the data in the table to calculate the marginal distribution, and we really want to make sure that we're doing this in percentages, okay, of the row or of the column totals. Okay, so it just depends on which, there are always two marginal distributions. Okay, I'm going to go back to the previous page here. It depends on whether they're asking us to find the marginal distribution of the survey responses or the marginal distribution for the gender, in which case there were only two right there. Okay, all right. And the other thing that we do when we're examining a marginal distribution is we often then take those percentages, which we'll discuss here in a moment, and we make a graph to display the marginal distribution, okay? So I did a little bit of setting up here for us. It wants us to examine the marginal distribution of the chance of getting rich example from example 1. And we're going to do the marginal distribution of, I think what they're implying here is not the marginal distribution of gender, but the marginal distribution of their response for what do they think their chances are of getting rich. And so that's why I put that variable right here. I just called it response. You can see I listed each of the 5 responses here. And now what I'm going to do is I'm going to need to look back on the previous page and I'm going to calculate what percent do each of these responses make up of the whole. Now notice my denominator is 4,826. I am getting that from the fact that there are 4,826 total people in this survey, and to change these to percents, I'm going to take each of these numbers here, the 194 down to the 1,083, and I'm going to divide each of those by the total. Okay, so I'm just going to fill these in here for you. If you punch this into your calculator and you kind of roughly carried it out to one decimal place and switched it into a percent, this is what we're looking at roughly for the percentages of each of these responses. Okay, so we're saying like there was about 29.3% of the people answered that there was a 50-50 chance that they think that they would have a more than middle class income by the age of 30. Okay, so I have calculated the marginal distribution for their responses. I have those here, and now up above here we had filled in another way to examine a marginal distribution is to make a graph. Okay, so I'm going to make a bar graph. It's a very typical graph that you use to display a marginal distribution. We're going to title this, we could have titled it, I guess, responses, but this is a little more descriptive here. Chance of being wealthy by age of 30. Okay, these are already filled in here. This is actually already constructed for you, although I will say the one thing that was missing on this graph that we definitely should add is we should add context. What are these things? Good chance, almost certain. Oh, that's the survey response. And what are these numbers? Oh, those are percentages. So I put percent there. And then you can see roughly these bars go up roughly about as high as what each of these percentages are here. Okay, again, huge AP tip. All graphs that you make, the axes need to be labeled, and then you need to include the context of what are those numbers representing, percents, what are these words representing, the survey response. Okay, now that's a marginal distribution. You can remember that because those percentages are found in the margins. Okay, there is another type of distribution. It is called a conditional distribution. A conditional distribution of a variable describes the value of that variable among the individuals that have a specific value of another variable, or in other words, it meets a certain condition. Okay, let me give you some examples because that might sound a little bit confusing here. Okay, what a conditional distribution is it's based on a reduced sample. So in other words, if I said, look, given that someone was a female, okay, so now I'm not talking about the 4,826. I'm talking about out of just the females, what's the percent that a girl would answer a good chance? Okay, now I'm just going to talk through that here with you for a second. There's a certain way mathematically to kind of label this. Okay, you give a capital P here means the probability, which is what we mean when we say what's the chance of. Okay, And then there's a vertical bar that kind of goes right down the middle of these parentheses, and the vertical bar is read given that, okay? And so what comes after the vertical bar is the part that we're saying given that. So I'm going to write the word female here. So we're going to read this, given that someone is a female, and this feels a little backwards because then we put on the left side, we're looking for what's the probability that someone answered a good chance. Okay, so I want to scroll back to the front here to this original table, and we can see here that there were a total number of 2,367 females. So we're saying given that someone is a female, I'm going to squeeze this over here, 2,367, out of just those females, and that's what I mean by the reduced sample, how many of them answered a good chance? Well, let's look back. How many of just the females answered a good chance? Oh, 663 of them answered a good chance. So that's my numerator. And then I would divide those two to get the percent. Okay, that is what we mean by a conditional distribution. Okay, we're going to select the row or column of interest. Okay, so it depends on what we're talking about. In this example here, the column of interest was females, given that someone is a female. Okay, you're going to use the data in the table to calculate the conditional distribution, just like I demonstrated there. And then you could make a graph to display the conditional distribution. And often what is used to display conditional distributions is one of two things, either what we call a side-by-side bar graph, that's my preference, or a segmented bar graph. Okay, one of those two. Okay, what you see at the bottom here is just a template. Given that, and then in my example, you know, if someone is a female, what is the percent of answering a good chance? Okay, and there are always two sets of conditional distributions for every two-way table, because you could do it for the columns or you could do it for the rows. Okay, so let's take a look here at, this is asking us to calculate the conditional distribution of opinion among the males. Okay, so when it says among the males, that means the males are going to be the reduced sample size. Okay, so that's what I'm going to just focus on now. What I have in yellow here is what I want you to look at. Okay, so if I were going to calculate out of just the male, so given that someone is a male, okay, my denominator here is going to be just the male total. That's the 2,459. Okay, and then I would want to fill in like their answers for each of their responses here, kind of like this. Okay, and if I divide these out, this is roughly what I get for the percentages. Okay, so just to talk through like what these mean here, and I kind of filled in off to the side. Whoops, sorry, that jumped down here. Okay, whoops. All right. Okay, so what do these percentages mean? Okay, like right here, what does a 30.8% represent? Okay, well, what that represents is that represents the probability that given that someone is a male, okay, because remember, that's what our reduced sample size was, it was just the males, that 30.8% is the probability that they would answer a good chance, okay, because my numerator there, the 758, came from the males that answered a good chance. Okay, we could do the same thing for the females. I'll just do that really quickly here, but you would divide, you know, each of their totals, okay, and then you would take 96 divided and so on. I'm just going to fill in the percentages here very quickly for you. And there is that. Okay, so the question is, what would be the probability? Okay, now you're going to have to be careful about this because this is something different. This is a conditional probability, but look at what this says. Remember, this vertical bar is read as given that. So this is saying, what's the probability given that someone answered almost certain? Okay, well, let's look at this. Almost certain is talking about all of these people right here. Okay, so now I'm calculating a conditional distribution of gender among the responses, okay? So given that someone said almost certain, so now I'm talking about just those people, 1,083, what is the probability that someone was a female from that group? Well, 486 would go in my numerator, okay? And that comes out to 44.9%, okay? So how is this used here? It says, based on the survey data, can we conclude that young men and women are actually very different in their opinions about the likelihood of their future wealth, okay? And it says, give appropriate evidence to support your answer. Okay, this is where the either side-by-side bar graph or a segmented bar graph comes in, okay? So I'm going to take these percentages that we have here, how the males answered and how the females answered, and we would take each of those, and you could either make, I'm going to start on the right here, you could make, this is called a side-by-side bar chart. Okay, you'll notice the two bars are right next to each other. I have a little key off to the side. The females are the dark blue. The males are like just kind of the empty red. And we see, these are the percentages here. We can see the percent of females right next to the percent of males that answered almost none, etc. Okay, now here's what we're looking for. If these bars in each of these categories are roughly the same height, and they're not here. I mean, maybe in one category they kind of are, maybe a little bit here. There's a dramatic difference here. There's a big enough difference here and here. But if these bars were roughly the same height for all categories, that's when we would say that there is, if they're the same height, we would say there's no association between gender and their response. Okay, so knowing that someone is a male, that doesn't really tell you how they would respond. If you're seeing some differences, though, that means there is an association between gender and response. Like if I told you, hey, I'm not going to tell you the gender, but I'll tell you this person answered some chance, you would be more inclined to say that person was probably more likely a female than they were a male, because females tend to answer some chance more frequently than males do. Okay? Having an association between two variables means there is a difference. You can see that difference in the bar chart. Over here is a segmented bar chart. The segmented bar chart is a little different. It's stacked. This whole column is males. They start, and it's like accumulation that goes up to 100%. This little blue part here is the percentage of males that answered almost no chance. Then added to that is the percent of some chance until you get to the end, and it totals 100%. What you would look for in a segmented bar chart is you would be looking to see if these areas of these colored sections are the same. I think it's a little easier to distinguish over here looking at the side-by-side bar chart, but the green you can really tell. There's a significant difference in area, which was the some chance category, which is what I was referencing here. There was a difference, okay? So here's what we could say when we're comparing these, okay? We could say that men are somewhat more optimistic than women about their future. Men are less likely to say some chance versus females. Okay, I'm going to cite some evidence here. Okay, these are my percentages from up above. You can see that on your paper. Men are more likely, okay, when you start seeing differences between gender and their response, that means that that's evidence that there is an association, okay? And they're more likely to have answered almost certain, okay? And I'm giving this numerical evidence here just to kind of cite and compare. The almost no chance and the 50-50, those were pretty much the same for each gender. Okay, very important that an association in no way means cause and effect. Okay, finally here on the back, this just kind of summarizes, if you're looking at a side-by-side bar chart, the bars have to be different heights for male and female if there's an association, okay? If there's no association, then the bars are pretty much the same height for male and female. Okay. If you are looking at a segmented bar chart, the sections would have different areas if there is an association, and there's no association if they have similar areas. Okay. Lastly here, this is describing a mosaic plot. You can look at this, just read this part down here at the bottom. This is just referencing that there were students and teachers who were surveyed what their favorite math class was. If you just use a segmented bar graph, you don't really get the fact that there were only 20 teachers who were in the survey, but there were 100 senior students. A mosaic plot stretches out and allows along the x-axis to kind of show that there were more students who were surveyed than teachers. This is not a bar graph. I know we said with bar graphs you want to keep the bars the same width. A mosaic plot specifically does stretch out the width to show that the sample size for that group was bigger. Okay, there is an assignment down here.